Here we'll talk about the direction of friction. What is the direction of friction? That is very obvious, right? So here an object is there, a force F is acting on the object in this direction, so the object is moving in that direction. So that means friction will be acting in the opposite direction, because friction will always try to prevent the relative motion between the two surfaces, right? So not exactly the motion of the object, but the relative motion is prevented by friction. Friction will try against the relative motion of the object, right? So friction acts in the opposite direction. So that is very obvious. Now here two forces are acting on the object, 10 Newton force here, 8 Newton force here, but anyway the net force is 2 Newton, that is in this direction, so friction must be in the opposite direction in this case also. But what about this case? Two forces are acting, F1 and F2, in the opposite directions. Now we don't know which is the bigger force, right? If F1 is greater than F2, the net force is in this direction, the object is moving in this direction, so friction must be in the opposite direction, right? So we have to consider different cases, right? Depending upon which force is bigger, the direction of friction will be decided accordingly, right? Yes. Now take this example. So here what happens, this object is not moving, even though there is a force acting on this object, so this object is not moving because friction is acting on the object in the opposite direction. So here also we know the direction of friction, even though the object is in equilibrium, right? Not moving. Now, if friction was not there, so where would the object go? So if friction was not there, this object will move in this direction. So that means friction must be acting in the opposite direction, right? So it is very clear the direction of friction is in the opposite direction to the direction of the applied force, right? Because just think of this. If friction was not there, so where would the object go? So friction works in the opposite direction. That's all. Alright, yes. So now you take this example. Now here a block is kept over another block. Okay. Now the force is applied only on the lower block. Okay. So this object is moving in that direction. Okay. So what is the force that makes the lower block move? That is the applied force in this direction. Now the upper block also is moving. So what is the force acting on the upper block? That is the frictional force between these two blocks, right? That is the force that is making this object move in the positive direction. Okay, that means what is the direction of friction? The direction of friction is not opposite to the direction of motion of the object. For the upper block, which is moving in this direction, positive direction, the friction is also in the positive direction. So friction is in the direction of motion of the object here, because friction only prevents the relative motion of the object. It will only try to prevent the relative motion between the two surfaces, not the motion of the object. But here what happens, the friction helps the motion of the object. Actually the upper block is moving in this direction, that is because of friction. Do you understand? So in that case, the friction for the upper block, the friction is in the positive direction only. Okay, but the same friction for the lower block is in the opposite direction. What are the forces acting on the lower block? The force, applied force in this direction, and the friction in the opposite direction, right? But for the lower block, the friction is working against the motion of the object. But for the upper block, the friction is only helping the object move, right? That means for the upper block, the friction is in the forward direction, same as the direction of motion of the object. But for the lower block, it is in the opposite direction. Do you understand? So these are some of the cases where we have to decide, right? So what is the direction of friction, right? So we will do some simple questions based on the direction of friction, right? Yes. Now let's start with some simple questions. Okay. And hereafter in all our questions we are going to consider the coefficient of static friction and coefficient of kinetic friction to be equal. But we know that the coefficient of kinetic friction is a little less than the coefficient of static friction, right? But this difference is so small that it can easily be ignored. Henceforth, in all our questions, we are going to consider the value of mu s, that is the coefficient of static friction, to be equal to the coefficient of kinetic friction mu k, and we will simply denote this by mu. So mu stands both for the coefficient of static friction and coefficient of kinetic friction, right? Because there are only a very few questions which has this difference, right? This difference between the static and the kinetic friction. So that is required. Otherwise, in most of your questions, so these values are taken to be equal. Alright, so mu stands for both mu k and mu s, right? So that means the limiting friction, right? The limiting friction equals the kinetic friction. That means, so this graph is something like this, right? It increases as the force increases. Now this value will also increase, right? The friction will also increase. Once the limiting friction is reached, okay, the maximum amount of friction is reached, and from there onwards it will remain constant. It will not decrease its value, it will remain constant. So that's what we are going to consider. But previously we have considered this value to be a little less, right, the kinetic friction to be less than the maximum friction, but henceforth we are going to consider this value to be same. The limiting friction is same as the kinetic friction. That's all right. Yes, now, so yes, this is one point you have to know. So just mu, that's what we are going to use for all our questions henceforth. Okay. Yeah. Here a block is moving in air with speed 20 meter per second, right, in the horizontal direction. See, when the object is airborne, right, so that means no contact with the surface. What are the forces acting on the object in the horizontal direction? No force, so the speed does not change. The object is moving in the horizontal direction without any force, so speed 20 meter per second, that does not change. But when the object comes in contact with the surface, then there is a force in the horizontal direction. That is the frictional force in the opposite direction. This frictional force will slow down the object, so the speed decreases. Finally, the speed will become zero, so the object comes to rest. So we have to find the time taken for the object to come to rest and also the distance covered. Alright, yes. Now, what are the forces? Only forces acting on the object are, the only force is the frictional force, right? So that is mu mg in the opposite direction. That's all. So force is known, and also the acceleration is known. Then from force we can find acceleration. So acceleration is known, we can find the time taken to cover a certain distance. Alright, yes. So what are the forces acting on the object? So the force is the frictional force, right? What is the formula for frictional force? So mu mg, but it is in the opposite direction, right? In the opposite direction, so you add minus mu mg, right? Because the object is moving in this direction, but friction is acting in the opposite direction, minus mu mg. So when you have the force, then what is the acceleration? So minus mu g. Okay, so divide by m, that's all. So force divided by m, so that is the acceleration. So acceleration is known, right? So then we can use our basic equations of motion to find the time taken or whatever is asked in the question. The velocity becomes 0, alright? So we know that, so v is equal to u plus at. So but what is v? The final speed, that is 0. The object comes to rest. Initial speed, so that is the speed initially, so 20 meter per second. And acceleration, so what is the acceleration? That is this one, so mu g multiplied by t. So that's all. So that will give you the time. So this gives you our required time. So that equals 20 divided by mu g. So that is the time taken for the object to come to rest. Okay. So but mu value is also given 0.2. So it is 20 divided by 0.2 multiplied by 10. Okay. So that means, so that's all. So this is 10. Okay, yes, so that's all. So that is the answer. So this is 10 seconds time taken for the object to come to rest. So 10 seconds, that is the answer. Now we also have to find the distance. So we can use the formula, similar formula. Which formula can be used? Because time is known, we can use s equal to ut plus half at square, right? Because time is known, or yeah. So use this formula only, s equal to ut plus half at square. Yes, so what is u? Initial speed, so that is known, 20 meter per second, and the time taken that we have found 10 plus half a. The acceleration is this one, so mu g. So mu g is what? So mu is 0.2, so the g is also known, which means it is 2. So minus 2 multiplied by t square. T square is 10 square. So that's all. So this is okay, let's calculate that. 200 minus 100. Okay. So that's all, that is the answer, 100 meters. So that is the distance covered by this object, okay, on the ground. Okay, so it covers 100 meters in 10 seconds. Okay, 100 meters in 10 seconds before it comes to rest. Okay, so that is the answer. Here a block is placed on an inclined plane, we have to find its acceleration. Alright, so let us find the forces, right, acting on this block, right? What are the forces acting on this block? The gravitational force in the downward direction, you have to take its component in the direction of its motion, right? Yes. Similarly, against this gravitational force we have this frictional force. Okay, so let us use both the forces. Let's find the acceleration. Okay, now what are the forces acting in the normal direction, because we want normal reaction, because frictional force, so the formula is mu times n, normal force. So let us consider all the forces acting on this block in the normal direction. So what are the forces acting in the normal direction? In the normal direction. Okay, so in the normal direction, n is the force acting in the upward direction, normal, and against which we have the component of the gravitational force in that direction. Okay, yes, so what is that angle? 30 degrees. So mg cos 30 degree. Okay, so minus mg cos 30 degree. So that equals 0. Okay, so that's all. That will give you our required normal reaction, right? So m is 4, so that is 4 g, right? So 4 multiplied by 10, cos 30 is root 3 by 2. So this gives you the value. Okay, this is 20 root 3. So this is the value of normal reaction. Okay, done. Now we consider along the plane. Okay, now what are the forces acting along the plane? Now again the component of the gravitational force along the plane. So what is the component in this direction? That is mg. This angle is 30 degree, so that means that is 60 degree, mg cos 60 degree or sin 30 degree, right? So mg, okay, sin 30 degrees. And opposite to this we have the frictional force. So what is frictional force? Minus, so mu multiplied by the normal force. Okay, so that equals the mass times the acceleration, right? That is the formula for the frictional force. But this normal force is found here. Okay, that can be substituted. Okay, so what is this? This is 4 multiplied by 10 and sin 30 1 by 2 minus mu. So mu is 0.3 multiplied by this normal force is found here, that can be substituted. So 20 root 3 equals mass 4 times the acceleration. So that's all. That will give you our required acceleration. That is, so this is 20 minus, so this is 20 multiplied by 0.3, so that is same as 3 multiplied by 6 root 3 divided by 4. So that's also, that is the acceleration, or we can write it as 20 by 4, so that is 5 minus 6 divided by 4, right? So 3 by 2, so 1.5 multiplied by root 3. So that's also, that is the acceleration of the block, okay, along the incline. But is it positive or negative, right? So we have to check that, right? This value is smaller, right? 1.5 multiplied by 1.7. So this is smaller than 5. This is a positive value. Sometimes you may get negative value. That means you have to reject this case. So it is not possible, right? The object will not move in the opposite direction, right? However strong the frictional force is, the object will not move in the opposite direction. It will only slide down. Maximum it can stay at that position. If the acceleration is negative, you are getting negative value acceleration, that means the object is not moving, right? It will not move in the opposite direction. It can only move in this direction down the plane, or it will be in equilibrium. So if you get the acceleration negative, so we have to assume that we have to consider this object to be in equilibrium, so acceleration is 0. Okay, but in this case we are getting acceleration positive only, which means it is sliding with this acceleration, right? So 5 minus 1.5 root 3, so that is the answer. There are two situations given in the question. In the first case, it is a rough surface. That means you have to consider the friction also along with the other forces. In the second case, it is a smooth surface, so no friction. See, the object takes certain time to reach from the top to the bottom, right? That is twice as much time as in the second case, right? So we have to find the time taken in these two cases. For finding the time taken, you have to first find the acceleration. So let us find the acceleration of the block in the first and second case, right? Yes, let us find it one by one. So in the first case, we have friction also, all right? Yes, now let us consider this first case. Okay, so that is the first case. So what are the forces acting on the object in the normal direction? Okay, in the normal direction. So what are the forces acting in the perpendicular direction? So what are the forces acting in the perpendicular direction? So that is the normal force in this direction, normal force. Okay, yes, normal force. And then the component of the gravitational force in the normal direction, right? Gravitational force is acting in the vertically downward direction. Its component, what is its component? That is mg cos theta, right? Theta only, same angle, mg cos theta. These two forces balance each other, right? Because no other force, so no vertical motion, right? No motion perpendicular to the plane. So that means the normal force and the gravitation force component, they balance each other. So N must be equal to mg cos theta. Okay, so we got the normal reaction. Okay, done. Now let us take the perpendicular direction. Now along the plane. So what are the forces acting on the block along the plane? Okay, now we have to take the component of the gravitation force along the plane. So that is mg sin theta, because that is 90 minus theta. Mg sin theta. Yes, so mg sin theta. Okay, yes. Now also we have the frictional force acting in the opposite direction, right? Friction force in the opposite direction, because the object has a tendency to slide, okay, against which we have the frictional force. So what is the frictional force here? Minus the frictional force, so that is mu normal reaction. But that normal reaction we have found already. Okay, let me write it here. So normal reaction. Okay, so that must be equal to mass times the acceleration. Okay, so this normal reaction is found here. Okay, so let us substitute that. So mg sin theta minus mu normal. So what is normal reaction? Mg cos theta. Okay, so that is mass times the acceleration, or if you divide this by the mass of the object, so that is the acceleration. Okay, so acceleration is found. When acceleration is found, we can find the time taken. Okay, so what is the time taken for the object to reach the bottom? Suppose the length of that slope, so that is taken as say L, d, right, distance. Okay, now what is the formula for distance? D, or S equal to ut plus half at squared, right? Ut plus half at squared. So that equals yeah, so ut, right? So u is 0, right? Initially the speed is 0, so 0 plus half at square, but a is the acceleration that we have found here. So from that we can find the distance. Okay, so at square. So that gives you the time taken. So time taken equal to square root of, this is 2d divided by a. So that equals square root of 2d divided by a. But a is found here. So we found a here. So what is the value of acceleration? M can be cancelled. G sin theta minus mu g cos theta. So that's all. So g sin theta minus mu g cos theta. So we found the time taken in the first case. Now second case. Okay, case 2. So case 2, it is smooth surface. Smooth surface means what? You don't need to consider the frictional force, right? So you don't need to consider this is same normal reaction, but you don't need to consider this frictional force. Okay, so that's all, rest of things are same, but we can do one thing. Let us not do the calculation again. We will not do the calculation again. So when the surface is smooth, simply you put mu equal to 0. That's all. That's all. Now mu is 0. That means the surface is smooth. So whatever we found here, so there you substitute mu 0, you will automatically get. Why would you want to do the calculation again? Except that this term will not be there. So that is equivalent to taking mu value 0. Okay, so substitute mu equal to 0. So that will give you the time taken. So let us take the time in the first case t1. So time taken here t2. So that equals, so substitute mu 0. So that is square root of 2d divided by g sin theta. Okay, so that's all. This is the time taken in the second case. Now it is given that the time taken in the first case is twice the second case, right? So that means, so t1 is given to be 2 times t2. So that means t1 is what? Okay, this value, square root of 2d divided by g sin theta minus mu g cos theta. So that is t1. So that equals 2 times this one, 2 square root of 2d divided by g sin theta. Okay, so that's all. Let's simplify this to get the answer. We can square both the sides. We can cancel this 2d. So 2d can be cancelled. So if you cross multiply, so it is g sin theta equal to this 2, if you square it is 4. 4 multiplied by g sin theta minus mu g cos theta. Okay, yes. So this g also gets cancelled. So this will give you mu value. So the value of mu from this is, so what is the value of mu from this? So if you take it to this side, 4 sin theta. Okay, 4 sin theta minus sin theta, which is 3 sin theta, divided by cos theta. So which means, yeah, 3 sin theta by cos theta is tan theta, and 4 times that. So 3 by 4 tan theta. These are all just calculations. Okay, so that's it. So that's all. This is the answer. Mu equal to 3 by 4 tan theta, right? That is dependent on theta, right? Depending upon the angle. See, for example, if theta is 45 degree or something, so we'll get the value of mu 3 by 4. So that is the value of mu. Okay, so this is the value of mu, right, for which the given condition is satisfied. So in the first case, it takes twice as much time as the second case, right? 3 by 4 tan theta. So that is the value of the coefficient of friction. Okay, yes. Here a block is kept in an inclined plane, and to keep this block in equilibrium, a force of 1 Newton is applied in the horizontal direction like this. Now we have to find the direction of friction. What is the direction of friction? Suppose if you withdraw friction, the object slides down. So the friction will be acting in the opposite direction. That's all. So if the object has the tendency to move up the plane, so friction will be acting down the plane. You understand? So friction is against the other forces, right? Yes. Now let us calculate the total force acting on the object other than friction. What are the forces acting on the object along the plane? Okay. See, along the plane. Okay. Let's consider the upward direction to be positive. Okay, upward. Any one direction you have to take positive, right? This upward direction we have taken to be positive. Okay. What are the forces acting on the object? The component of this 1 Newton force in the upward direction, right? So that angle is theta only, same angle, right? Corresponding angle. So 1 cos theta. So 1 cos theta. Okay, 1 cos theta. Okay. Now the component of the gravitation force, right? What is the gravitation force? Downward direction. You take the component along the plane. So that angle is 90 minus theta, 0.1 g sin theta, right? So mg sin theta. So minus 0.1 mg, right? 0.1 g sin theta. Okay, and the friction force, right? Let us take the friction. What is the direction of friction? We don't know. Let us take the upward direction. Because we have taken the upward direction positive, let us take the upward direction to be the direction of friction. So plus the frictional force. Okay, so that equals 0 because the object is in equilibrium. Okay, so this is the first equation. Okay, done. Now what you have to do, let's simplify this. So what is this 0.1 g? G is 10, so it is okay, so this is 1 only, so 1 sin theta. So that means what is the frictional force? So frictional force equals sin theta minus cos theta. That's it, sin theta minus cos theta. That is the frictional force. Okay, now let us calculate for different cases. First case, if theta equal to 45 degree, then what is the friction? So that is sin 45 minus cos 45. So both have the same value, so that is 0. So the frictional force is 0 when theta is 45 degree, right? No friction. Okay, now if theta is greater than 45, so theta is greater than 45. If theta is greater than 45, what is the frictional force, right? So sin 45, so sin not 45, theta minus cos theta. But is it negative or positive? See, we have to see sin more than 45. If the angle is more than 45, so we have to know some basic trigonometry. So when the angle is more than 45, sin theta is more than cos theta, right? So sin theta is more than cos theta. So this is positive value when the angle is more than 45. So friction is positive. Positive means what? It is in the upward direction because we have taken the friction to be in the upward direction. So this is upward. That means in the first case, in this case, theta is greater than 45, it is a friction acting in the upward direction. Now theta is less than 45, okay, so same thing, so friction equals sin theta minus cos theta. But this time when the angle is less than 45, cos theta is bigger than sin theta. So that means this value is negative, so that means friction is negative, so it is acting in the downward direction, that's all. So the friction is acting in the downward direction, okay, downward direction towards the bottommost point, right, towards this point. When theta is less than 45, so theta is more than 45, it is in the upward direction. So okay, 0 here, friction, if theta is exactly equal to 45 degree. So that's all. So that is the answer. here we have to find the maximum and minimum value of the force F for the system to be in equilibrium, right? Yes. So maximum force, right? What if you apply the maximum amount of force? So this block has a tendency to move to the left, right? You apply the maximum force. So that means, what is the direction of friction? When the object has the tendency to move to the left, so friction is acting in the opposite direction, right? Now if you apply the minimum amount of force, if you apply minimum force, that 50 Newton force, that will dominate. That means the friction will be acting in the opposite direction, right? So for maximum force, if you apply maximum force, the object tries to move in this direction, so friction will be in the opposite direction. Now when you apply the force F, minimum value of the force F, then the object has a tendency to move to the right, because we are applying only minimum force F, so that force will be more now. So the object has a tendency to move to the right, so friction will be in the opposite direction, right? Even though the object is in equilibrium, but still friction has different direction, right? So if you apply minimum force, the friction will be in this direction. If you apply maximum force, the object will try to move in this direction, so friction will be in the opposite direction, right? So for F minimum, so for F maximum, suppose you apply maximum force. If you apply maximum force, remember, if you apply maximum amount of force, the object will try to move in this direction. It is not that it is moving in this direction, it will try to move in this direction. If you withdraw friction, the object will move in this direction. Because there is a friction, the object is in equilibrium. But when you apply maximum force, the object will try to move in this direction, so friction will be acting in the opposite direction, right? Yes. Now for maximum, so you apply the force F max acting in this direction, right? Negative. Then minus 50 Newton, that is in the opposite direction, so minus 50. Friction force in the opposite direction, right? Positive direction, that also minus them. Minus the frictional force. What is the frictional force formula? So that is known, right? So mu mg. Okay, let me write. So mu mg. So that equals 0, right? Equilibrium. So 0. That's all. So F max. So the maximum force. So that equals 50 plus mu mg. So mu is known. So that is 0.4. And the mass of the object is also known, 8. And g is 10. So that gives you our value of F max, which is so 32 plus 50, so that is 82 Newton. So that is the maximum force, right? If you exceed this force, right, if the force is more than 82, the object will move in this direction, right? Negative direction, right? This direction, right? If the force is less than 82, maybe the object is in equilibrium. Okay, yes, done. Now for F minimum, okay, for minimum force, which means we are applying the minimum possible force. So that means that force, 50 Newton force, is more than this force. So that means the object will try to move in the right direction, right? So in the positive direction. That means the friction is acting in the opposite direction. Okay. So that means what are the forces acting on the object? 50 Newton in that direction, 50 Newton. Minus this force F. So but that time we are applying only the minimum force. So F minimum, opposite direction. So friction is also acting in this direction. Because the object tries to move in that direction, friction acts in the opposite direction. So minus. Friction. What is the friction force? So that is same thing. So mu mg. So that equals 0, because again equilibrium. So that gives you the value of F minimum. So that equals, taking it to the other side, is 50 plus mu mg. So what is mu mg? 50 minus, sorry, 50 minus mu mg. So mu here is okay, same thing. So 0. So same force only, 0.4 and 8 multiplied by 10. So that equals, so 50 minus 32. So that is 18 Newton. So that is the minimum force. You understand? So minimum force. Suppose you apply a force which is less than this 18 Newton, right? Less than the minimum. That means the object will move to the right. Okay, because this force is very small, so the object will move to the right. Okay, then if it lies between 18 and 82, if it lies within this range, the object will be in equilibrium. Okay, so the directions of friction is important, right? In these two cases we have different directions. Even though the object is in equilibrium, if the object is moving, right, if the object is sliding, it is very easy to understand the direction of the friction, right? If the object is sliding in this direction, obviously friction will act in the opposite direction. But here what happens, the object is in equilibrium, but still the directions are different. Okay, so if you withdraw that friction, what is the direction of motion of the object? So friction will act in the opposite direction. You understand? So in these two cases, the friction has different directions. So maximum force, minimum force. So F must lie within this range for the object to be in equilibrium. Okay. Here also we have to do the same thing. We have to find the minimum and maximum force F for the system to be in equilibrium, but this time the object is kept on an inclined plane, okay, not on a horizontal plane, right? Yes. Now, but the idea is same. Let us first find the minimum force. So for minimum force, F minimum or maximum, any one of them you can find first. So F maximum. When you apply maximum force, the object has the tendency to move upwards, right? Like along the plane, right? So in the upward direction. If you apply minimum force, the object will try to move in the downward direction. So F max, if you apply maximum force, the object will try to move in this direction. So against which we have the friction, which means friction will act in the downward direction. Do you understand? So that means what are the forces acting on this object, right? But before that, we have to find the normal force, because to find the frictional force, we need the normal. Let us consider the normal direction. Okay. So for F max, let's consider the normal direction. What are the forces acting in the normal direction? So in the normal direction, normal force, okay, so normal force, and also the component of this F in the normal direction. So what is the component of this force in the normal direction? That is F sin theta, right, but downward, right, F sin theta. So that means N is equal to F sin theta, okay, because N is in the upward direction, F sin theta, downward direction, and the component of the gravitational force. What is the gravitational force? The downward direction. Take its component mg cos theta, right, mg cos theta. So that is also downward direction, so plus mg cos theta. So this is the normal force, okay. So this is a normal force. We can use it when you find the frictional force, okay. Yes. Now let us consider the force along the plane. See, what is the force acting along the plane? F cos theta, F cos theta. So now along the plane, this is in the normal direction, now along the plane. So F cos theta in this direction, so F cos theta, and the component of the gravitational force, right, that is in the opposite direction, mg sin theta, in the opposite direction, minus mg sin theta. Now the frictional force. So what is the frictional force here? Now the friction, see, we are applying maximum force, so friction will be in the opposite direction. So friction is also in the downward direction, so minus mu n, that equals 0, equilibrium, so 0. So this n is what we found here, that we can substitute, okay. So that's it. So we get F cos theta, okay. F is what we need to find, okay. Anyway, so minus mg sin theta minus mu, this n, so n is found here, so that you can write F sin theta plus mg cos theta equals 0, okay. So from this we can find F. So F equals, so what is the value of F? This mg sin theta, okay, we can bring it to one side, so mg sin theta, what are the other, plus mu mg cos theta, plus mu mg cos theta, okay, done, divided by, so here F cos theta, here also we have minus F mu sin theta, which means cos theta minus mu sin theta. So that's all. This is the force we have found in the first case. That means we found the maximum force. So this is F max. Okay, that's all. So that is the maximum force. Similarly, we have to find the minimum force. So when you apply minimum force, the object will try to move in the downward direction. So that means the friction will be in the opposite direction. Again, we have to do the same calculation, but we are not going to do that. See, you remember this idea. We can always do this. F minimum. If you want to find F minimum, instead of doing all the calculations again, because we have arrived at the answer, now we can make small changes. Only the direction of friction is different, right? Otherwise, all the calculations are the same. Direction of friction is different. So what you do? Simply, wherever you have mu, replace that by minus mu. Okay, we can use it as a shortcut, right? Wherever you have mu, replace that by minus mu. Whatever you get, that is the minimum instead of maximum. That's all. Because the only difference is the direction of friction. So replace mu by minus mu. So that will give you our required answer, F minimum. So that equals, so rest of the things same. So mg sin theta, so this is same, minus mu becomes minus mu. So minus mu mg cos theta divided by cos theta, and this becomes plus, right? So plus mu sin theta. So that's all. So this is the maximum value and this is the minimum value. So one of them you find, any one. So minimum force or maximum force, any one of them you find and replace mu by minus mu, you get the other one. Okay, so that's all. So this is the range in which this force should lie so that this block is in equilibrium, right? Otherwise this block will either move up or down the plane. Okay, so that's all. This is the maximum force and that is the minimum force. Okay, but the answer is given in terms of tan theta, right? So we can convert this into tan theta also, right? Because sin theta, cos theta, here also we have cos theta, sin theta. So we can convert this into tan theta. How will you do that? So let us simplify this further. So this can be written as tan theta. So that means you divide this all the terms by cos theta. Okay, if you divide by cos theta, you can take out mg. And then if you divide by cos theta, sin theta by cos theta. So that is tan theta. And then cos theta by cos theta, so that is 1, so which means tan theta plus mu. So that's all. And divided by, here also you divide by cos theta, so 1 minus mu tan theta. So 1 minus mu tan theta. So that is the answer, right? So that is the maximum force. Similarly we can find the minimum force. So again do the same thing, divide by cos theta. So that is okay, or replace mu by minus mu, that's it. So mg multiplied by tan theta minus mu divided by 1 plus mu tan theta. So this is the minimum force, so this is the maximum force. Alright, so that's all. So that is the required answer. Isn't this question similar to the last question? It's even easier because the force F is acting along the plane, right? So let us do the same method. So let us first find the normal reaction. So let us first find the maximum force, right? So for F max, so the maximum force, let's consider the normal direction. So what are the forces acting in the normal direction? So the normal force in the upward direction, so N. And then downward, the component of the gravitation force, mg in the downward direction, so its component, right? mg cos 45, right? mg cos 45, they balance each other because no contribution from F in the normal direction. So mg cos 45 degree. Okay, so that is a normal force, right? mg divided by root 2. Okay, normal is found. Now along the plane. So now we will consider all the forces along the plane. What are the forces? F in this direction, F. Okay, so F in this direction. Now we are finding maximum force. That means the object has the tendency to move in this direction. The friction will be in the opposite direction, right? So F in this direction, friction the opposite direction, and similarly the component of the gravitation force, so minus mg, okay, minus mg sin 45. The friction is in the opposite direction. Object moves in this direction, friction in the opposite direction. That means minus. So minus mu multiplied by the normal force. So that equals 0. Okay, yes, that's all. So normal force can be substituted from this. So this is F equals mg sin 45. Sin 45 is 1 by root 2 plus mu. Okay, so mu is equal to, okay, so mu normal. So what is normal? mg cos 45. So mg cos 45 is 1 by root 2. Yes, now, so that is F maximum, right? So this is the maximum force, so F max. So that equals, so if you take mg by root 2, if you take it out, so we get 1 plus mu. So that's all. So this is the maximum force. Okay, done. Now minimum force, will not do all this. We can directly write the minimum force. So like we have done already. So the minimum force equals same thing except the sign of mu. Okay, we can write it as 1 minus mu. So that's all. That is the minimum force. But it is given that the maximum force, right? The maximum force is 3 times the minimum force, right? So the force required to move the object in the upward direction, that is 3 times the force required to prevent the object from sliding, right? That means the maximum force is 3 times the minimum force. It is given that F max equals 3 times F minimum. Okay, so that's all. So we have found both. So just substitute it here. So we'll get Okay, mg divided by root 2 multiplied by 1 plus mu, so that equals mg divided by root 2 1 minus mu. Okay, so that's all, 3 times this multiplied by 3. So mg by root 2, that gets cancelled. 1 plus mu is 3 times 1 minus mu. Okay, so what do you get? 1 plus mu equal to 3 minus 3 mu, so that means 4 mu. Okay, so 4 mu is equal to 3 minus 1 2. So let me write it. So 1 plus mu is equal to 3 minus 3 mu. Okay, 3 minus 3. So 4 mu is equal to 2. So that means mu is equal to 2 divided by 4 or 0.5. So that's all. So that is the value of mu, right? So that's also, it is very simple, just like the last question. So you find F max. Okay, so for maximum force, the friction is in one direction, so minimum friction is in the opposite direction. So that we have directly written by replacing mu by minus mu. So maximum force, minimum force are found, but some relation between them is given. So using that, we got the answer mu equal to 0.5. Okay. Here we have two blocks which are kept on an inclined plane, one behind the other by a distance of root 2 meter. Now these two are sliding along the plane, but they have to come to the same horizontal level. So time taken for that to happen, right? That's what we need to find. See, these two blocks are at a separation of root 2 meter. So that means this distance should be covered. So this root 2 meter is the relative distance between them that should be covered. You understand? So relative distance is root 2 meter, right? So we have to find the relative acceleration. For that, we find the acceleration of both these blocks, then find the difference, that will give you the relative acceleration. Using that, we can find the relative distance, which is root 2 meter. Okay, yes. One is behind the other. See, these two blocks have the same mass, right? But their coefficients of friction, so they are different. So one of them has mu value 0.2, the other one has mu value 0.3. They have different values. If they have the same coefficient of friction, they'll move with the same acceleration. So this gap will remain the same, right? But one of them has coefficient of friction 0.2. That means that is less than the other one. That means the frictional force between the first block and the surface is less compared to the other one. So that means it will move faster. You understand? Less the coefficient of friction, less is the frictional force. So the object will move faster. So that is why it is able to cover that distance of root 2 meter. Okay, so let us find the acceleration. How to find the acceleration? So let us consider all the forces along the plane. Okay, so first block. Okay, so what is the force acting on that block? Now the component of the gravitational force in the downward direction. So let us take the component. So mg in the downward direction, its component you have to take, right? So this angle is 45, mg sin 45. Okay, mg sin 45 in the downward direction. Mg sin 45. Okay, in the downward direction. Friction is acting in the opposite direction. So what is the friction? Minus mu into normal force, right? So normal. That equals mass times the acceleration. But what is this normal force? So let us write the normal force also. Mg sin 45 minus mu. Okay, let me write mu only, so we can substitute the value of mu later. So normal reaction. What is normal reaction? So let us consider the forces along the normal. Normal in this direction, component of gravitational force in the opposite direction. So normal n, mg. So that is mg cos 45. Mg cos 45. That means normal is same as mg cos 45. That equals mass times the acceleration. So we can get the acceleration. So what is the acceleration here? So mg, so we can divide by m. So we'll get g, okay, sin 45, 1 by root 2 and mu g cos 45. Okay, so that means g divided by root 2, right? Sin 45 or cos 45. Both have the same value. So 1 minus mu. So this is the acceleration of the object. Okay, this is generally we have found the acceleration. Now you substitute the value of mu 0.2, we get the acceleration of one of the blocks. And similarly 0.3 will give you the acceleration of the other block. So let us take the acceleration to be, say, a1, the first case, a1, the acceleration of the first block, any one of the blocks, say 0.2. So substitute that. So g divided by root 2, 1 minus 0.2. So that will give you the value. So g by root 2, 0.8. Okay, now a2. the acceleration of the second block. So that is g divided by root 2. So this time you substitute the other value of mu. So that is 0.3. So that equal to g by root 2 and 0.7. Now we want the relative acceleration. Okay, so relative acceleration. The relative acceleration. So just the difference, that's all. So call it a only. So a equal to a1 minus a2. a1 minus a2 equal to 0.8 divided by minus 0.7, 0.1. So it is g by root 2 multiplied by 0.1. Okay, so if you take the value of g to be 10, so it is 10 multiplied by 0.1. So simply 1 by root 2, that's all. So this is the relative acceleration. Once the acceleration is known, we can find the time taken to cover a distance of root 2 meter, right? So for that we can use our basic equations of motion. So s equal to ut plus half at squared. So initial speed is 0. So s distance to be covered is root 2. So 0 initially plus half a acceleration, that's what we found here, 1 by root 2 multiplied by t square. Okay, so that's all. So if you multiply, t square equal to 4. Okay, t square equals 4. So that means t is equal to 2. So that's all, 2 seconds. So that is the time taken for these two blocks to come to the same horizontal level. That means the relative distance covered is root 2 meter by the other block. Alright, so that's all. That takes time 2 seconds. Okay, so that is the answer.